be ChatGPT, and the other one is the tutorialpoint.com. Okay, so you type here tutorial point assembly, and you will send this one to assembly programming tutorial point. Okay, and they told you that you need a NASM. Okay, so you can download NASM or MASM. Okay, so click next, and it said what is assembly language. It is a blah 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 and the blah blah blah. This is direct to the machine language programming. You can communicate with the BIOS, external devices, execute instruction, process data. Okay, so word meaning 2 byte, double word 4 byte, quad word 8 byte, paragraph 16 byte, kilobyte 1024 megabyte. If it says 2 bytes, okay, so let's make it clear. Okay, if you said 2 bytes, this one 2 byte, meaning 8 bit is equal to 1 byte. Okay, so if you said 2 bytes, so meaning 16 bit. Okay, because you have the, let's say, FF. You remember our 1248, 1248, and 1248. So from here, so you have 8 bit, which is 1 byte. Okay, so this 1 byte can create characters from A to Z. Okay, but you need 60, let's say 65, capital A. How many? This is 1 byte, right? So 2 byte meaning 16 bit. Okay, that's it, only that. So 4 byte 32 bit. Yeah, because FF is 1 byte, this is 1 byte, FF another byte, FF another byte, 8 plus 8 times 4 is 32 bit. Okay, so if there is a 0 X notation, then followed by FF 0. 8 byte, so this one 64 bit. So if you run your calculator, the one I teach you, you can see it. Okay, just explore that. See, we have this this binary number. 1, 2, 4, 8, 16, 32, 6, 4, 1, 2, 8. 2 to the 2, 2 to the 8. So the hexadecimal is there is A to F. Okay, so you learn that. So now you are understanding binary arithmetic because you have already our understand now how to read binaries, and now we are going to a negative binary value expressed in 2's complement notation. See what you are going to do in 2's complement, inverted the number plus 1. See, number 53, you reverse the bit, meaning reverse. As you can see here, they reverse the bit. This one becomes 0, this 0 become 1, this 1 become 0. Reverse, reverse. If this 2 0, this is to 1, then plus 1, and this is the answer, and that is negative 53. So that's how you do those complement of this negative number. To convert into a negative number, that's the one. Okay, so what happened? 53, when you reverse the bit and plus 1, it becomes negative 53. Okay, now subtract 42 from 53. So 53, 42, reverse the bit of 42, add 1. You see they reverse 0, 1, 1, 0, 0, 1, 1, 0. So get the invert of the 0, 0, 1, 1. So you reverse the bit, add plus 1, then numbers negative 42, then 53 minus 42 is 11. So this is it. Okay, that is how to get the negative numbers. Okay, so accessing the memory, you have the fetching the instruction from memory, decoding or identifying the instruction, executing the instruction. Okay. So this the one we are telling you that it is the in register, but in memory it is inverted or Indiana's little engine. Okay, so that's the thing. Read this one. The process when it is in register 0725, but once it is written in the memory, it is the reverse. It says here the processor is the store data in the reverse byte sequence. Okay? Low order byte. So this is the Indianes, the little engine. Okay. The processor may access one or more bytes of memory at a time. Let us consider hexadecimal number 07258. So this 07258 is this one. Okay, the number will require 2 bytes of memory. Okay, the high order byte are the most significant byte, and the low order byte is 25. Okay, so the high is 25 because it is on the right side. Okay, but the processor stores data in reverse byte sequence. Okay, so once the CPU is running, it will reverse the data. Okay, absolute address, a direct reference of specific location. Segment address is the segment of the data. Okay, so after that you click next. As you can see here, some IBM equivalent compatible. Local environment setup. So these are the assembler you can use. There are many good assemblers. We have Tatasam, Turbo, Borland Turbo Assembler, Microsoft Assembler, GNU, and the NASAM, and NetWide. There's a pre-download of NASAM. You can click that. Download NASAM, and that one is in Linux. This one. But there's a nationwide assembler NASAM, and click this one and you can download that. There's an English also. Not Linux. For Windows there is. So I downloaded the NASAM. You click here, NASAM US. Okay, so after that you click the download here. Download this and extract it. But better use the stable, and once you click this, use the installer for Windows. Okay, you go to Windows 64 and choose this installer. This one, you choose this one. You try this too. This one is only 2 files. This one is with the PDF document. Okay, so after that, in NASAM, remember this, there is data section. Okay, there is a BSS symbolical. As you can see, the section data, the BSS is declaring a BSS section is that BSS, then that text. So this is the sequence. And if you have something you want to ask, what is that BSS? That BSS in NASAM. It is a symbolic symbol. It will give you an answer that is a see, and we will give you an example. Okay. So meaning this is the area wherein you put those variables reserved. So okay, so it says here the NASAM nationwide assembler, the BSS section is used to declare uninitialized data. So meaning this data is uninitialized, there is no value, it is just any space. Okay, so you ask your ChatGPT about what is point BSS acronym meaning. This will give you the meaning of that one as a block started symbol. See, now we have a ChatGPT, and you can ask anything on this. So that is the block started by symbol. So it is a block of contiguous block of memory. Okay, so let's go here, and you installed now, then continue reading. So the text section, meaning it will actually, these are also segment. Later we can test that. You can change that into a segment. Okay, meaning EAX is equal to BX. So this is the syntax. We have a label, mnemonic, operand, and comment. The mnemonic is mob. Label is the integer count, increment the memory. Mob, total 48. Then there are some labels to jump, but here there's no label. So the mnemonic is mob, and the operand is count. Increase is the mnemonic, and count. Mob, total, the operand is total, comma 48, and the comment. And these are the comment. Okay, so the hello world program in assembly, so they give you this one. Is there any register here? Register, or here. Later you will learn the register, and they give you section here, and you click this one for the live demo. Okay, then ask GPT for all the codes that you want, and you go. Always you save this one by pressing Control D as in dog. Okay, T meaning Control plus D. This one is to bookmark that one in your browser. Okay, so once you press Control D, and it will Control D, and it will assembly basic program, Teachyourself, then done. Okay, so now from here, as you can see, you try to execute this one, and you will see here hello symbol len not defined. Main ASM 5 symbol len not defined. So meaning this code is lacking of something now. Okay, so there should be len here, and wait for a while. So this one is lack of len EQU dollar minus message. Okay, so this one is the length of our string to be printed. Okay, so as you can see here, len meaning the dollar. Once you start in data, this will deduct the length of the message. Okay, so that's why from here in as you can see here, there is A, B, C, D going up, another going down. You can do like that, and this is the system call always 0x80 in NASM. Okay, so we're going to run our program, execute, and there should be hello world. Okay, so what happened here, this is the length, the dx is the length of this state, of this one, of this variable. Okay, then it counts the message to write how many, so it counts here. Okay, then if you add here +1, let's try to add +1 here and execute. As you can see, there is another character added in front of hello world. So if you make it this one 2, if you create this one 2, as you can see, when you execute, there are 2 dots. Okay, so if you put here 10, then you execute, so there's an error already with so it's meaning it's adding, but that's why 16, it's okay. Maybe 10 is 10 is just So what happened here? Okay, listen carefully. Uh, this dollar, it points here. Okay, it points to the area of memory. Then it minus the message, and that is the link. Okay, that's what happened. That's why there is a dollar for the last text, meaning this is the last text here in the hello world that they put in my previous video. They put a dollar sign, so that's the one. Okay, that's what happened. So after that, this is that text global start. So meaning text is the code, data are the data being processed. These are the register AX, BX, CX, DX. They put E because it is 32 bit. If you put R, that is 64 bit. But I don't think they have the same call kernel. I never try, but you can test if you want. You can change this to, let's say, RDX, RCX, RBX for 64 bit. I don't know if they have the same system called style. And try to execute, and I think it's not. Oh, see, instruction not supported by 32 bit. So meaning this assembler is running only in 32 bit. So there is another option on creating a. You can learn first this one. Actually, better to learn in the 8-bit or 16-bit only. In AX, BX, CX, DX. Okay, so meaning this section is, we are going to set the code segment. So we can rename this section as segment. Okay, that's why there is data segment. Data segment. We have this one is text or code, or because when we read text followed by code, that's what we read in the structure of the text BSS. There is a text BSS that we read. Okay. This one is add AXBX. This one is 10 plus 10. This one, let's say 7. So the previous record of this one is 10, and it will add. Okay, in adding, this is what happened. The AX is 10 plus 3, so meaning add AX EBX, the value of EAX is 13. Okay, it will go here. Then if you add another number, add 5 to EAX, then 13 plus 5 become 18. So it's just adding, but they are registers. Okay, so from here you can execute this, and the same thing happen. Hello world, but we change the segment to section. So it's better you use segment, code segment, stack segment, meaning these are the code segment, but they put section. I don't know why. Maybe to make people confused. So meaning this they start now. Okay, so meaning if your program start in 00, this is 001, the created hexadecimal value here of the command move ADX line. Once you save this one and dump in Linux, that's why better you download Linux to complete your tutorial. I have a Linux here. I run in Kemo, and I can run all those. But this is just for you to play with it. Okay, so from here you can change this also till Leia. Okay, meaning load effective address, and we try to execute that. Same thing happen. See, the same thing happen when we choose this Leia, load effective address of the message. So you ask now the chat GPT the difference between Move and Leia. I think Leia is the effective address. So from here also, this message is treated as a label. Okay, remember that. And this len also is treated as a label. Okay, meaning it is considered as a label just to confuse us. No, I'm just kidding. Meaning you can do like that and execute, and the same thing happen. EQ to radio level. Sorry, not the len EQU. Sorry, only the DB. Okay. Sorry for that. Okay, we execute and you see become hello world. So meaning you can put direct here. Okay, that's why you can put here DB another and blah blah blah. Okay, then 0xa the terminator, that 0xa. Okay, and you put here another message 2, or you can do like this, message DB and message DB hello world hello. Okay, and then you are going to repeat this command, then you copy this and you put here. Let's see, then interrupt 80 again and you put here message 2. Let's try first the length, if still running or not. Okay, let's try to execute this. As you can see, it become 2 times printing. Okay, so we are going to put here len 2. Okay, and going to create here another len 2. Len 2 equal to dollar minus message 2. Okay, so then you can execute this, and that's what's happening. So exit, call the kernel. So that's what happened. How come become 3 times? Okay, so never mind. At least you know how to do it. We have the len 2 here and the message 2. We have the len 1 here and the message. Okay, let's try to. This one should be AX to 1. Let's try to double the code here. Then we execute that one. Yeah, correct. So what you are going to do here, that's why I'm telling you, this one is become double. That is the use of the macro. Okay, you search for the macro in Assam, and you go here in ChatGPT and give me a sample of macro in hello world. I train my robot to answer me completely. Hello, Give me example of power and low word nasa assembly. You can try also. Depends on how you assembly. Okay. Okay, so this one is the section data, and you see there is end macro. Okay, so what you're going to do is to enjoy coding and try to learn, continuous learning. But better you install Linux in your system, so complete all the requirements in creating your own OS, your own operating system. Even it is small, but it is funny, and you will become happy on that. And let's try to run this, execute, and as you can see, hello world 2 times, but we just call the macro, no need to repeat again. See? So what happened here, this is our data segment. Okay? So you can name this one as a segment. But in tutorial there is a section. They put like this, so the person or the one who will trying to learn assembly is not confused. So meaning this is the code segment, so this is all code. So this is data segment, so all is data. So if that is the other part is BSS, and you can. Okay, so it says here print because the name of this macro is print. And he doubled our this one. There is a percent. This is a Linux style, but it's okay. In Linux there is percent, address of the string. There's a percent because an argument, sorry. Because in Linux, in 8080 assembly, there is a percent. So here is an argument. Okay? EDX2. This first argument, second argument, and because it print 2 here, so meaning it will print these 2 argument. Okay? The first one, print hello. So this is the first argument. This is the syntax. Okay? This is the syntax called the macro. Hello, and then what is the hello? It is on top our label. Actually, I told you this one can be a label. So a label can be the same thing. Okay, so that's how you can play a assembly language. You ask GPT to give you a sample. Okay, and we will continue this tutorial, but try to understand first all, review all this, and there are some questions you ask GPT and try to teach yourself. Okay, so you focus here in the registers. This is the important thing. You have to know the registers. Okay? First you have to memorize these general registers, control registers, segment registers. Okay? This is the area in processor. You cannot do memory to memory. You cannot do transaction memory to memory. This is the CPU. The CPU have a register of AX, BX, CX, DX, AL, because this one is 16-bit. If you put it AL, 8-bit, AH, 8-bit. So that's why there is ABCD, AL, BL, CL, DL, then AH, BH, CH, and DH. Okay, so this is it. See? It's here already. So no need to follow my... So to understand this told you AX the accumulator, and read what is the primary use of accumulator, used for input and output and arithmetic instruction. So, and it return the return function, it's not included here. The return value is accepted by accumulator. Okay, if somebody is calling function on the stack, the return value is in AX. Oh, this is the base. Okay, this is the counter, the looping, and this is the data, dx. Okay, then there are pointer, instruction pointer, stack pointer. This used in the stack. Structure pointer is the pointer of tracking the number of continuously. It's asking where is the next instruction. Oh, that is in instruction pointer. You see, it executed the next instruction. Stack pointer is the pointer of the stack. Base pointer is the base pointer of the stack. Okay, so later on you will see from 0 to 15 bit, 16 to 31, ESP, direct BP. Okay, so those are source index, destination index, from 0 to 15, 16 to 31, then the overflow flag. These are the overflow flag, the data flag, string data, and this one is interrupt flag, trap flag, sign flag if it is negative or positive, 0 for negative, set to 1. You read. Okay, so once there are some who don't understand, I will try my best to explain it to you. Okay, so as you can see, they forgot here. Okay, so this one must be declared for linker. There is a GCC, also compiler. Okay, so that's all for today, and see you on the next instruction. I give you a chance to review this, and there's another thing important for you. You are going to look for the interrupts. What are the interrupts? Interrupts, so do not have basic interrupts. See, there's no interrupt, so meaning it's not complete. I don't know, I never explored all of that. But you ask ChatGPT, give me all interrupts in system code for all the devices. Something like that. And it will give you the interrupt. See, this is a system call. It's nice, right? So many things to learn. So what they call is okay, how to read this. As you can see in our program, they put AX number 4, so they call function number 4, and the EBX is the role of the EBX is the descriptor of the std out, std out, so meaning this is the output print on the screen, function 4, and you are going to look for 4 here. What is 4? See, it's to write. So it's called the function write to file. Okay, and terminate the process, exit. Okay, and 4 is to write. Okay, so So return the value into AX. Interrupt 80, system call number. The argument to the system call is go to BX. So the BX is the argument. Okay? So the arguments here, so they call number 4. This is the calling that's how they call the kernel, okay? Meaning it's the one controlling all this code. So they call number 4 write. So meaning we are going to write on the standout, std out. So if you do not know how to, if you want to explain more by ChatGPT, you can highlight this, okay, and copy this, and you put here Control B, and please explain line by line. Press enter. Okay, and as you can see, move instruction, load the 4 in AX, and write system call. See, so I told you, then the argument is what? The VX4. The 4 is a system call number for write. Okay, you can explain. So meaning that is the system call, the AX. In a 32-bit, load the value 4 into AX. Then the BX is the file descriptor, std out. So meaning the std out is, because there is std in and std error 2, and the std out is 1. That's a constant. Std out is always standard output terminal. This is it. Okay, then ECX number 1, the address of the string, and number 2, length of the string, and that's why, and they call the kernel. Okay, that's how you teach yourself, class, for all those who want to learn assembly. Next time I will teach you how to install Linux, and you can create your own operating system. Okay, so try to explore little by little, then dump that. You can dump that, download the NASAM, do it in your PC, and try to load the syntax, learn how to compile. You ask the ChatGPT, and he will give you the code on how to compile this code. NASAM minus FBin, something like that. Okay, and you can read the NASAM. PDF. Better you install this installer. There is a PDF of NASAM. Review the 300 plus pages and enjoy. Okay, so that's all for today. Thank you for watching. Hoping all of us will love assembly language, because we know now how to read the binary orally, and that's it. And we have this wind calculator here, the one I told you for the programming. You use this calculator in computation. You want to see the effect, and you put it in the programmer, not the standard. Click here, there is standard, that is the standard 0, 1, 2, 3. And there's scientific, and for the programmer there is this one. Okay, so let us teach ourselves, enjoy every code that you made. So From here, there's a tutorial here. You can copy the code. Once you have the, let's say you have the NASAM, let's say you downloaded your NASAM already. So what you're going to do is to search for your NASAM. Okay, and I think I install NASAM in F. Okay, so this is the NASAM. And this is the one I told you. Please read, enjoy reading this about open this with Google. Okay, you click open with Google. No need Acrobat Reader. Okay, and it is now in your Google. You can see there exe here, exe combat the Windows in running a program. Only those so you'll read this 308 pages. Okay, so that is easy for you, and because you do not know how to read binary, how you can learn assembly. That's the base. So if you are now in NASAM, then there is a notepad here. Hello point assembly, and we try to paste here our code. Say paste here the code from the tutorial, and let's try to compile that. Okay, let's try. So you have to put NASAM help. You can put greater than NASAM help.txt, enter. If you do not want, it should be on the screen, then you can read like this. Okay, so so many things. Okay, so then we have to put NASAM minus F bin then hello point asam minus O output. It's minus O output. Awesome. So let's try to see the text file. Let's continue our lesson. So as you can see, if you type NASAM help, then you put here more piping, then you can find str minus 0. Let's try this. So error requires an argument. So another thing I just want to show only, because NASAM help, then you can do the piping here. Find str slash I minus O. Let's try. If you encounter band command line, you have to find str and slash question mark, and you see what's wrong with you. Okay, so use search formatting file. So /r and /I, not case sensitive, so we can use /r right there. So find str /ir /i /i /r. Okay, so if you cannot find the /o, you notepad our help here. We created a help here. Here's a command. So find str slash then the string, then I don't want our tutorial, but use a search string literally /l. Let's try /l. /l, meaning only /l. So let's try this find str /o without any argument, command line. Okay, so just now we have the file that we converted into text, NASM help point text. Okay, so we'll pad that one, NASM help point text, pad. Okay, this is the redirecting that we use. So let's look at the /o. Negative O, the output file. In the F here, you can use format. You use L32. You can finish bar, yeah. So you can use window 32. CORF for window 32. Okay, so like that. So after that, we're going to type CLS here. Directory, and let's try now our where's the one we created, hello point awesome, NASM minus F. What's the format? 32. Hello point awesome minus hello point object. Okay, so this is it. Then we have our hello object, and this one you can link, but the thing is we do not have the link code here. Try to link, but I think it's not working. We have to find the linker, and I have a link in my MASM 32. Let's try this link. Link / system console hello.bj, and syntax error in a subsystem. There should be console. Okay. And save for a file. Okay, so we're going to find the ML or linking that file. So because this is NASM, so that's how it is. Okay. Just keep continuing. I only now I try this NASM, and never used it before. Okay, so I just use the masam and the other one. So okay, next time we will do it, and wait for the next video regarding another important things you can learn about assembly. So you can use Win 32. Okay, let's try Win 32 here. Some Win 32 here. That's how you read the syntax. Okay, like I told you, you can use all these, try, learn, explore. Okay, I'm just teaching you how to teach yourself. Okay, now you can teach yourself because you know what are the rules of syntax already.